First part of this is worth 13 points. 1, 1, 1, 1, 1, 2, 2, 2, and 2 for a grand total of 13. If you read carefully, some of them are really simple. For instance, how many oxygen atoms are in one molecule of this stuff? It's just 3. That molecule has 3 oxygen atoms. They didn't ask you about a bunch of them or how much it weighs. What's the atomic mass of this? Now I have to break this down. I have Na2CO3, so I have 2 NAs, 1 carbon, and 3 oxygen. And Na weighs 23, so 2 of them would weigh 46 grams. 1 carbon is 12, so that's another 12 grams. 3 oxygens, check the chart. 1 oxygen is 16, so 3 oxygens is going to be 48. Added together, that's 106 grams. 106 grams. This next one is just the same question worded differently. How many grams make up 1 mole of that stuff? Same answer, 106 grams. The next one is kind of a trick question. How many molecules are in 1 mole of? It wouldn't matter what we wrote there. How many molecules are in 1 mole of anything? It's 6.02 times 10 to the 23rd. That's the answer. That's Avogadro's number. So if we had a mole of this stuff, which are sodium carbonate, Na2CO3, and we want to know how many total oxygen atoms, we'd have 6.02 times 10 to the 23rd. And look, every single one of these has 3 oxygen atoms. So we simply do that times 3 oxygen atoms, and that's going to equal, like, well, 18.06 times 10 to the 23rd. But your calculator will say 1.806 times 10 to the 24th. So those are each worth 1 point because they were kind of tricky but straightforward answers. Next one are more like what we had for our mole quiz. How many moles are in 15-gram sample of Fe2O3? I start by writing down what they gave me, 15 grams, and I'll put it over 1, Fe2O3. I know that my next thing, if I have grams of Fe2 over there, I'm putting grams of Fe2O3 right there. What I really want to know is moles. That's why moles is going to go on top, moles of Fe2O3. If only I knew the relationship between 1 mole of this stuff and how many grams does 1 mole weigh. So I have to add up what 2 Fe's and 3 oxygen weigh. 2, and Fe, according to the chart, is 55.8 grams per mole. 3, so when I multiply that by 2, it's 111.6. 3 oxygens, 1 oxygen, 16 grams. 3 times 16 is 48 grams. That equals 159.6 grams. So I need a 159.6 there. 15 divided by that. Let me erase here. And I would get 0.09 moles of Fe2O3. Another one, similar. What is the mass of 0.04 moles of magnesium hydroxide, MgOH, taken twice? Start with what they gave me, 0.04 moles of MgOH taken twice, and put it over 1. I get ready to multiply by a fraction. Of course, moles of MgOH2 goes on the bottom. What goes on top? Whatever the mass is, which is grams of MgOH2. What's the relationship? Just need to add it up. 1 mole of that stuff is Mg. There's one of them. Parentheses says that there's OH in parentheses, and that's twice. So that means that I have 2 O's and 2 H's. Magnesium is 23 grams. Maybe I did that one wrong. 24.3. 24.3 grams. 2 oxygens, 1 oxygen 16 times 2 is 32 grams. 2 hydrogens, 1 hydrogen is 1 times 2 is 2 grams. That's going to equal 58.3 grams. That goes here, 58.3 grams. Let me get rid of some junk here. 0.04 times 58.3 equals 2.3 grams of that stuff, magnesium hydroxide. How many silver atoms are contained in 100 grams of silver? Ooh, finally one where I don't have to add up a bunch of stuff. I can just check the chart. If I have 100 grams of silver, that's Ag, I'll put it over 1. I know that grams of silver is going on the bottom. I don't know the relationship between atoms and grams. All I can figure out is how much a mole. So before I get to atoms, I'm going to put 1 mole of Ag, silver, on top, and then check the chart to find out that silver weighs 107.9 grams per mole. All that would let me do is cross off grams and grams, and I wouldn't have my moles of silver, or that leave me with moles of silver. So I'm not done. I know that I'm writing moles of silver on the bottom. What I really need on top is atoms. Do I know the relationship between moles and atoms? Why, yes, I do. I know that 1 mole of anything, silver included, is 6.02 times 10 to the 23rd. That will cross off. 100 times 6.02 times 10 to the 23rd divided by 107.9 equals 5.58 times 10 to the 23rd atoms of silver. Next one is a percent composition. All you have to do is figure out the part divided by the whole times it by 100. This compound has 2 things. It has nickel and it has sulfur. 6.35 grams is nickel. That part is nickel. 6.35 grams out of the whole of 9.56 grams times 100. That equals 66%. Some of you just did the math and said, well, there's only 2 things. It must be 34% S. And I'm okay with that. If you really needed to find out, you'd take 9.56, you'd subtract 6.35 to get 3.21. I didn't even do it on my answer key. I think it would be 3.21 grams of sulfur divided by the 9.56 grams times 100. That would equal the percentage of that. That is part 1.